Good morning, first period. Sorry I couldn't be here with you today. So in my absence, I would like you to watch this video, attempt the questions to the best of your ability, and then work together on the Check Your Understanding worksheet that you will get from the sub. So I will begin by going through this note outline with you. This lesson, 2.5, is all about how we could solve what we call polynomial equations through the process of factoring. So that's why we have spent so much time learning procedures, formulas, and the concepts behind factoring. So this comes from sections 2.2, 2.3, and 2.4. All of that information is going to be needed in this section, but actually in a lot of other sections starting from now until the end of the school year. There's a lot of things we can use factoring for. Okay, but factoring is not used on its own. It's used in combination with what's called the zero product property. So the zero product property says that if you have any two factors, and actually there could be more than two, so just you have any factors at all, and if you happen to know the product of the factors, so in this case we're calling it a zero product, so if we have any two factors, A and B, and if A times B is 0, then there's a few things that must be true. So one of the things that could be true is that A could be the factor that equals 0, or B could be the factor that equals 0, or there could be the off chance that they're both 0. So that's just logic, right? We know that if you multiply anything by 0, then the result of that will be 0. Therefore, if the result of multiplying two things is 0, it stands to reason that one of those two things must be 0. Now notice it doesn't work that way for any other product. This idea only works when the product is 0. That's why it's so important for us to get 0 on one side of our equation, because I'll just give you like a few examples. So suppose I have a product equal to 1. Let's suppose. So that means A times B is 1. So I could say that A is 1 and B is 1, but I also could say it is possible that A could be 1/2 and B could be 2. The product of those numbers is 1. So it's possible that neither A nor B are required to equal 1. That's just one example. If I could think of another sort of prime number, so let's suppose the product was like 13. So you might say, oh, well, one of them has to be 13, right? The only factors of 13 are 13 and 1. That's true if I'm only allowed to work with positive whole numbers. But if I'm allowed to work with fractions or negative numbers, it's possible that A could be 26 and B could be 1/2, because if you multiply those, you get 13. It's also possible that A could be -1 and B could be -13. There's all kinds of possibilities where neither A nor B has to be positive 13. Only 0. 0 is the only product. Maybe I'll write that up here. 0 is the only product that must also be one of its factors. Just because of the nature of multiply anything by 0, you get 0. Okay, so we're going to use that logic in combination with factoring. The factoring is what creates the products, right? So just take a look for a moment at the fact that all of these equations are equal to 0. Even down here in example 3 and 4 and 5, and then put a fat star here. We're going to have to do something about the fact that this is not 0. Gasp, it's not 0. Ah, run for your lives. Okay, anyways, I want you to make a big note to yourself that in order to use the zero product property, you need to get one side of your equation, equal to 0. Okay, so in the first few examples, we already have that done for you. This first example here, we'll start with example 1a. This first example is just to illustrate how we handle our solutions and how we view our factors. So in example 1a, I want you to notice that there are two factors. They are binomial, so I'll stick that word in there, two binomial factors. So I want you to see them as like one whole thing. My first factor is x minus 11. My second factor is x minus 3. Notice that they're being multiplied together, so that's my product. And that product is 0, so that's my 0 product. I have a product equaling 0. So that means that either my first factor is 0 or my second factor is 0. Or if either one of them is 0, it would be a solution to the equation, because basically what I'm trying to do is solve. So if the x minus 11 factor was 0, then one solution I could get is positive 11. If x minus 3 is one factor that's equaling 0, then the second solution would be 3. So this had two solutions. It had two factors, which created two solutions of positive 11 and positive 3. These would be our answers to example 1a, 11 and 3. So now in example 1b, I have again two factors. But you might be noticing, well, it's really just one factor that's being squared, and you would be correct. We're both right. There's two factors, but they're identical. So we still technically think of this as having two solutions that are identical. There's two factors, that could potentially be 0. But if I solve them, I get the same thing. So I get a solution of negative 5 twice. So we call that a multiplicity of 2. And that just means that that just means that I have two factors that gave me the same solution, or two solutions that are identical, or one solution that repeated itself. That's kind of the meaning behind a multiplicity of 2. So we would still technically say there's two solutions, they just happen to be identical. Now in part C, there are technically three factors. There's 3, there's x plus 1, and there's x minus 6. Now, again, these are being multiplied together to give me 0. So I have to think about which one of these might be causing the 0. Well, it's not going to be the 3, because 3 is not 0. But it could be the x plus 1. That might equal 0. That would equal 0 if x was negative 1. It could be the x minus 6, because that could equal 0 if x was positive 6. So this again has two answers, two solutions. And the answers were negative 1 and positive 6. Now, in example 2, it's more of the same, but the theme with example 2 is that there are more than 2 and even more than 3 factors in a lot of these. In part A, we just have the 3 factors. So here I have a factor of x plus 3 being multiplied to a factor of x plus 8 being multiplied to a factor of x plus 7. So according to the zero product property, if either one of these factors was 0, then the whole product would be 0. So this one here, this factor would be 0 if x is negative 3. This factor would be 0 if x is negative 8. And this factor would be 0 if x is negative 7. So I don't know if you're noticing it, but your solutions should have the opposite signs from your factors. So in this case, I had factors of x plus 3, x plus 8, x plus 7, but I had solutions of negative 3, negative 8, and negative 7. So if you want, you can just sort of jump to your answers by just getting opposite signs. Now notice in B, we have a total of 1, 2, 3, 4, 5 factors. That means we're going to have 5 solutions, and we just need to find all of them. So you just take each factor and you set it equal to 0. I'm just running out of room here, so I had to kind of move off to the side. So the first solution would just be when x itself is 0. Because if you look at this problem, I'm taking my x and multiplying it to all these things. So if I plugged a 0 in right here for this x, and actually I'd have to plug it in for all the x's. So if I plugged in 0 for x, I'd have 0 times -2 times 4 times 7 times -1. But it doesn't matter what all these other things are. If I'm multiplying them to 0, I still get a 0 product. So that's why x being 0 is one of my answers. My next answer comes from solving this factor being set equal to 0. So my next answer would be 2. The next answer after that would be -4. Then this one here, the 2x plus 7 equals 0, might require a little bit of more thought since I have that 2 in front of the x. So you would subtract the 7 and then divide by the 2. So then that solution would be -7/2, or if you like decimals better, -3.5. And then our last solution would be -1. So I had 0, 2, -4, -3.5, and -1. So I'm going to write all of those here. 0, 2, -4, -3.5, and then -1. These are my 5 solutions for example 2. Lastly, in example 2c, I want you to take note of the fact that you have a total of 1, 2, 3, 4, 5, 6 factors. I've got a factor of x, I've got 2 factors of x plus 5, and I've got 3 factors of x minus 1. So when I take this factor and set it to 0, that's one answer, so I have one solution of 0. I have another 2 solutions for making x plus 5 0. So if I solve that, I'd have x equals -5 twice. So multiplicity of 2. Then I have 3 of these x minus 1s. So 3 times that could equal 0, and that would equal 0 if x is 1. So I have 3 solutions of 1. So we would say that's a multiplicity of 3. Now again, you might be thinking, what is the big deal about these multiplicities? Like, can't I just say that I have solutions of 0, -5, and 1? And the answer is yes. Those are our solutions, 0, -5, and 1. But remember, we're going to use this stuff to graph eventually in our next unit, so it will have an impact on the actual graph. So for now, I'd like you to think of it this way. You technically have 6 solutions. 1 of them is 0, 2 of them are -5, and 3 of them are 1. So we think of it as 6 solutions where only 3 of them are unique. But this one occurred twice. This one occurred 3 times. So technically 6 altogether. Okay, so in examples 1 and 2, the hard work has been done already. But in the rest of the examples, we have to get our equation to look like the way they did in examples 1 and 2. So this one already has one side equal to 0, so that's good. We want to make sure that one side of our equation is equal to 0, so that's done. And then we need to factor the other side, because we want the other side to be like a product, but a product implies you have factors multiplying together. So since this has the 3 terms, this was the style of factoring that we had learned to do using this box method, where the x squareds always went in our top left corner, and then our single numbers, like our constant with no x, went in the bottom. And then we knew that there had to be something here and here that eventually add up to 4x, but we're not sure yet how it's going to work. So the way we would do it is we would guess and check. So whatever goes here and here has to multiply to be x squared. So x and x for this one. And then whatever goes here and here has to multiply to -5. But I can use sort of an educated guess and check. I can I can recognize that I would want to use a positive 5 and a negative 1. Because then what goes here is what I get when I multiply x and 5, positive. And then what goes here is what I get when I multiply negative 1 and x, negative. And then if I added those together, since they're like terms, I would get positive 4x. So I'm guessing and checking, but I'm kind of educated guessing, knowing what these have to add up to. Then these dimensions, the length and width, those are the factors, because those were the things that I multiplied together to get the area. So my area, of course, is this, but I recognize that this is the result of multiplying this length by this width, or x minus 1 by x plus 5. Meanwhile, I still have my 0 on the other side, so now I have a 0 product, right? A product of things equaling 0. So that tells me that either the x minus 1 is 0, and I solve that and I get a solution of x equals 1, or x plus 5 is 0. And I solve that and get a solution of negative 5. So that would be my answer to this question, would be those solutions of 1 and negative 5. But the one nice thing about these problems is you can always check and see if that really is a solution. I can check by taking my answer and plugging it into my equation to see if it makes it true. So if I plug in 1 for x, I just want to see if it would make this part 0. So this would be 1 plus 4 minus 5. And yes, that does equal 0. So I definitely know that 1 is a solution. If I plugged in negative 5 for x, I would get positive 25 minus 20 minus 5. And that also equals 0. So both of these actually do make the equation equal 0 when I plug them in. But it would have been really hard to get to these solutions without knowing the factors. So factoring and getting those equal to 0 is the key. Okay, so in example 4, what we have there is like a classic GCF scenario, where this doesn't, it's not a trinomial, so I don't really factor with the box method. It's not like a difference of squares or cubes. So this is just a scenario where all you can do is take out a GCF. So I notice between the two terms I have an 8 and x to the third. So I'm going to factor that out. And then from here I would just have an x left, and then from here I would just have a 3 left. So those are multiplying together to give me 0. So again, it's a 0 product, right? 0 is right here. Product is right there. So I know that one of these factors has to be 0. Well, actually, if I think about this, I really have 5 factors altogether. I have 1 factor of 8, 3 factors of x, and then 1 factor of x minus 3. Well, I know that the 8 is never going to be 0, so I don't need to worry about that factor. But these x's could be 0 3 times, right? So I have 3 solutions of 0. And then this could be 0, causing me to have 1 solution of positive 3. So my answers to this one, I've got 0 3 times, and then I have 3 once. So 0, 0, 0, and 3. Okay, so in example 5, this is one of our special products. Not sure if you're noticing, but I've got a cube here and a cube there, because 216 is 6 cubed. So this is in the form of a cubed minus b cubed, which according to the formula says it can factor into a minus b and then a squared plus ab plus b squared. So according to that, I should be able to factor this into x minus 6, x squared plus 6x plus 36. Because if x cubed is a cubed, then x is a. And if 216 is 6 cubed, then b is 6. So this x minus 6, that was my a minus b. This x squared was my a squared. The 6x was my ab, and the 36 was my 6 squared from the formula. ab, a squared, ab, b squared. And I just used the SOAP. Same, opposite, always positive. Okay, but anyways, this is my product, and it's equaling 0. So I have one binomial factor and one trinomial factor that need to be set equal to 0. So from my binomial factor, I get one of my solutions of 6. And then as it turns out, this trinomial is not factorable. So there are solutions to it, right? There are some other solutions. We just don't know what they are yet. Not yet. Because there's other ways of solving quadratics other than factoring, but we haven't learned them yet. We're starting with solving by factoring. So I know some of my answers. I have an answer of 6, and then I have some other answers, but I just don't know what they are yet, so stay tuned to our future lessons coming up where we will teach you how to solve by other methods when factoring is not an option. But again, this trinomial here does not factor into two binomials, so we cannot find our answers by factoring. But it does have more solutions. We'll just have to stay tuned for that. But we can also find one of the answers at this time. Okay, last but not least, we gasped at this one earlier because, oh my goodness, how dare we have a non-zero number on one side of the equal sign. I need to get a 0 product, not a -6 product. So I'm going to add that 6 to the other side because I do not want it there. I want a 0 on one side, my 0 product. There's no like terms to add it with, so I just have 3 terms now on the other side, which is good actually, because then I can factor using this box. So again, I put my x squareds in this top left. I put my constant in the bottom right. And then I know that this amount, whatever it turns out to be, needs to add to this amount, and they have to add up to 25. So while I'm guessing and checking, I'm keeping that in mind the whole time. So I'm going to use bigger numbers when I'm factoring. Instead of like 2 and 2 and 3 and 2, I'm going to use 4 and 1. And then I'm going to put 6 here and 1 here, because 1 times 6 would give me 6. But look at this. When I multiply 6 by 4x, that gets me all the way to 24. And then I just have to do 1 times 1x to get 1x here. And then I have enough x terms that add to 25. So my dimensions would be 4x plus 1, and then 1x plus 6. Or my factors, so to speak, would be 4x plus 1, and then 1x plus 6. So those are the two factors. This is my length and width that multiplies to give me this area. But it makes it so much easier for me to find solutions to this, because now I know that either 4x plus 1 it must be 0, which would then give me one answer of -1/4. I also know that x plus 6 would have to be 0, which then gives me my second answer of -6. So I was able to get my two answers fairly quickly and easily after I did this process of factoring. Okay, so then again, the solutions to this equation are -1/4 and -6. So that concludes this video. Like I said, I want you to now work together at your tables on this Check Your Understanding worksheet. And then make sure you circle all the ones that you have questions on so that you can ask me tomorrow in class. I'll see you there. Bye.